What's today, the 17th? Don't forget to what? To give me... I really don't care about that part. Okay. I don't. It's not a big deal to me. It's just a video to help you guys out. I'm not doing it for anything else. All right, so the question was 25y to the third power over z to the second power. So the way that I'm going to baby walk you through it, the first thing that you want to do is you want to identify. Yes, ma'am? Do I have your notebook? I haven't checked it yet, that's why. Here. So the first thing that you need to do, and make note of this, and guys, honestly, the colors, I know that you might get annoyed by the idea of having to do the colors, but it really does help to break things down and helps you to see where we're splitting things up. So it's my strong recommendation that you utilize them. But whenever you have them in fractional form, the thing that you want to check first, you're first going to check if the denominator is a perfect square. The first thing that you want to look for is to see, is that denominator a perfect square? So z to the second power, is that a perfect square? Yes. So if it is a perfect square, do not simplify. Okay, even though you couldn't simplify anyway with this problem, but that's the rule of thumb. If it is a perfect square, do not simplify it. Okay? You don't try to see, okay, can I cancel it out with anything? You can do that later. You want to try and leave your denominator as perfect squared as it can possibly be. Okay? So what I'm going to do is I'm going to split this up into each component by term. So you have numerical terms and you have variable terms. So my numerical term that I have right now is the square root of 25. I have two variable terms as well. I've got y to the third and I've got z to the second. I'm going to split them all up into different components. So I'm going to go ahead and write them in different colors. So I've got the square root of 25. I've got the square root of y to the third. And then I've got the square root of z to the second. Okay, so they're all split up because they're all different terms. So now we're going to go ahead and take the square root of anything that we can. So let's go ahead and identify what our non-perfect squares are. Anything on here that is not a perfect square. Grant.
Y to the third.
Y to the third. So in this case, the square root of y to the third is not a perfect square. I want to go ahead and make it into a perfect square. I want to make it into a perfect square. How do I make y to the third a perfect square? Akshaya, separate it. So I'm going to take one of the y's out, so square root of y, and what am I left with? Square root of y to the second. Okay, so now I'm going to go ahead and rewrite all of this. I've got the square root of 25. I now have the square root of y to the second square root of y over the square root of z to the second. The next thing I'm going to do is I'm going to identify the perfect squares. Which ones are my perfect squares? Grant?
25 and z to the second.
25, z to the second. Any more? Y to the second. So here are my perfect squares. So what is the square root of 25? 5. What is the square root of y to the second? Y. What is the square root of z to the second? Z. And the only thing that is not a perfect square is that square root of y, so that remains as it is. Can I simplify anything? Nope. That's my final answer. Sorry. All right, let's go on to the next problem. So number 18 that you guys had in here, it seems only 55% of you got it correct. So that was the issue as well. So we have the square root of, 3x to the third over 64x to the second. Okay, 3x to the third over 64x to the second, all of that within square roots. So again, you need to check and see, is the denominator a perfect square?
Yes.
Yeah, the denominator is a perfect square, so we're not going to touch it. We're not going to try and simplify it with the numerator yet. Eventually you will have to simplify, but I don't want to do it yet, just in case, okay? So we're going to go ahead and break this all up. So the first thing I'm going to break up is my numbers. So I have the square root of 3 over the square root of 64. Then I'm going to break up with the variables. I have the square root of x to the third over the square root of x to the second. What are my non-perfect squares? X to the third and square root of 3, right? X to the third, square root of 3. Those are both non-perfect squares. So, square root of 3, can you factor it? No. Square root of 3 cannot be factored. So square root of 3 is going to be as simplified as we can get it. What about x to the third? Can we factor that? What are we going to factor it into?
Square root of x to the second and square root of x.
Very good. Square root of x to the second and square root of x. Square root of x to the second and square root of x. Okay, so let's go ahead and rewrite all of this. We know that the square root of 3 is as simplified as it's going to be. Square root of x to the third, we rewrote it as square root of x to the second and square root of x. And then the denominator, nothing changed. We're leaving it as the square root of 64 and the square root of x to the second. Now let's go ahead and identify those perfect squares. Which ones are my perfect squares? Good. 64, x to the second, and this other x to the second. Hi. She's in the 6th grade lab. She's got it written on her thing. Okay. All right, so we've got 2 x to the seconds that can be simplified. We've also got the 64 that can be simplified. So what's the square root of x to the second? X. Square root of 64? 8. And then, of course, square root of x to the second is, again, x. And then what do we have remaining? 3x. So we still have the square root of 3x that's remaining in our numerator. Now we check to see, okay, is there anything that we can simplify that is not in a square root? Jordan?
Nothing. Oh my god. 8.
Strong and wrong, dude. All right. Annie. Well, not subtract them, but you can simplify them, right? They're both divisible. You know 7 divided by 7 is 1. You know 20 divided by 20 is 1. So x divided by x is 1. So both of these can be simplified. So we'll just remove them. So then our final answer, we're still left with the square root of 3x over 8, which is not inside of a square root at all. And that's it. That's your final answer. Any questions? Okay. All right, so let's go ahead and do a couple more practice ones, because every single one of these problems, they were the simpler ones because they already had perfect squares for their denominators. I want to focus on ones that don't have perfect squares for the denominators, so then you see if you can simplify them. Okay. Pardon? She can come back in now, yes. She's allowed to. Oh, and Tanya. Can you go tell Tanya in Miss Johnson's room that she can come back in? Oh, thank you. Appreciate that. Huh? That is my other classes. So you guys are not doing the same thing. Huh? Yeah, there was a minion on there. Mm-hmm. All right, here we go.
How much time did you have to answer a question?
For you guys, you had 5 minutes per question.
I felt like 30 seconds or 1 minute.
You had 5 minutes.
No, it did not, but I felt like 8 hours.
You had 5 minutes per question to be able to do. All right, so if I had a problem like the following, let's say that we've got the square root of 6x to the 9th over 27x to the 3rd. So like I said before, what you need to make sure that you're doing is you're checking to see, can you have a perfect square? Like, is there a perfect square for the denominator? No. Neither one of these are a perfect square for the denominator. 27's not perfect. X to the 3rd is not perfect. So when you don't have a perfect square, when the denominator is not perfect, then you're going to go ahead and simplify if possible. Because sometimes when you simplify the denominator with your numerator, it might simplify to something that is perfect. So at this time, because I'm trying to get you guys to be okay with dealing with the quotients, the factors, or the fractions, If it's not perfect, I'm going to have it simplify to something that is perfect. Once you guys have that under your belt, then we'll talk about what to do when you simplify it and it's still not perfect. That's when we rationalize denominators. We'll get into that next week. Okay? So for here, what can we do to simplify? So I'm going to go ahead first. I'm going to break these apart so that way I can see them. I've got the square root of 6 and 27. And then I've got the square root of x to the 9th and x to the 3rd. So what can I do to simplify 6 over 27? Colin? Divide them by 3. So they're both divisible by 3. This is now going to become the square root of 2, God bless you, over 9. Is the denominator perfect now? Yes. It is now a perfect square. The numerator's not, but that's okay. I'm more concerned about the denominator. What about x to the 9th over x to the 3rd? How are we going to simplify that? Elijah? Well, I don't want to break them apart yet. I want to simplify them first before I start having to. So how do we simplify exponents? Subtract the exponents. That's what I'm looking for. So when it's exponents, so it's the same base, what I'm going to do is I'm going to take both of those exponents and I'm going to subtract. So that means we're going to have 9 minus 3. What's 9 minus 3? 6. So where is that x to the 6th going to go? Is it going to go in the numerator or in the denominator? The numerator. Very good. What will go in the denominator then if I've now removed all my x's? A 1. A 1 will now go in the denominator. It's important to know that because of the fact that my first value is dealing with a fraction, I want to make sure that my second value is still in fraction form. If I don't have that denominator anymore, I put a 1 there. A 1 works with everything because the nice thing about a 1, is it perfect? It's your very first perfect square, right? 1 times 1 is 1. That's right. So that's your very first perfect square. So the 1 works all the time in these situations. Okay? Now let's go ahead and continue through the process. The first thing that we want to do is identify anything that is not perfect. What's not perfect? 2. 2 is not perfect. Can we factor the square root of 2? No. Square root of 2 cannot be factored. So I know that the square root of 2 is just going to have to remain a square root of 2. The next thing I'm going to do is identify what is perfect. So if square root of 2 is the only thing that's not perfect, that means the square root of 9, the square root of x to the 6, and the square root of 1 are all perfect. What is the square root of 9? 3. What is the square root of x to the 6th? X to the 3rd. And what is the square root of 1? 1. So now I'm going to replace those positions. I know that, square root of 2 is going to remain a square root of 2. I know that x to the 6th, the square root of x to the 6th, is going to become x to the 3rd, so it now goes in the front. That's it for my numerator. On my denominator, the square root of 9 is going to be a 3, and the square root of 1 is a 1, and 3 times 1 is just 3. So there's my simplified answer. I want you guys to try this one on your own. Actually, I want to change that 10 to a 14. Change the 10 to a 14. I want you to try that one on your own. Yeah, because that's not perfect, so we're going to try and simplify. Yeah, but when you're subtracting them, if that's a negative, then put it to the bottom and it becomes positive, right? So you have more y's on the bottom than you do on the top. So technically you can take the difference, but wherever you have the more, if it's going to be a negative, you put it on the bottom to make it positive, right? So it'd be 1 over y to the second. Yeah. So if you subtract them, you're going to get a negative, right? But remember, negative exponents, we rewrite it as 1 over, and then whatever the base is to the positive exponent, which makes sense because you've got more y's on the bottom than you do on the top, right? Anybody finished?
No. Yes.
Oh, okay. 1, 2, 3, 4. 4 people. All right, I'm going to give a little bit more time. 5 people. All right, raise your hand if you got the answer. What do you think, Kendall? Close, but not quite. You've got a lot of good components in there, but there's a little bit of a mistake. Heaven? I can't hear you. You're going to have to speak up. Very good. X to the second square root of 7x over 10y. So let's take a look. The first thing we're going to do is we're going to pull apart numbers, variables, all of our like terms, right? So we have the problem square root of 14 over 200. We have the square root of x to the 10th over x to the 5th. And we have the square root of y to the 4th, y to the 6th, right? Now, our non-perfect squares are the 200 and that x to the 5th. Those are not perfect, so we're going to go ahead and simplify. How are we going to simplify for 200? What are they both divisible by here? 2. So if I divide both of these by 2, I know that this is going to become the square root of 7 over the square root of 100. I now have a perfect square on the denominator side. Same thing for here. X to the 5th is not perfect, so how am I going to simplify? Subtraction. So I'm going to subtract those two, and that's going to give me the square root of x to the 5th over 1, or square root of 1. Okay, and then y to the 4th and y to the 6th, both of those are perfect. And yes, technically you can go ahead and simplify them right now, but I'm trying to get you guys into a process here. Okay, so we're just going to leave them alone for right now. Okay, so now we're going to go ahead and focus on the things that are not perfect that can be factored. Can we factor the square root of 7? No. Can we factor the square root of x to the 5th? Yes. How do we factor it? It's going to be square root of x to the 4th and then the square root of x. We can factor this one. Everything else needs to be left as it is. So square root of 7 over square root of 100, and then this is going to be still over 1, and then square root of y to the 4th over square root of y to the 6th. What are our perfect squares? 100, x to the 4th, y to the 4th, y to the 6th. All of those are our perfect squares. What's the square root of 100? 10. So I have square root of 7 over 10. What's the square root of x to the 4th? X to the 2nd. Okay, we still have square root of x is still over 1. What's the square root of y to the 4th? Y to the 2nd. What's the square root of y to the 6th? Y to the 3rd. Okay, now we check to see if we can simplify anything. Can we simplify anything? Yep. These y's can still be simplified. Okay, this is basically saying, hey, you've got y times y on top, and on the bottom you've got y times y times y. So what can we cross off? 2 of the y's on top, 2 of the y's on bottom. We're left with just a y on the bottom. Okay, so this can be simplified to 1 over y. Now we piece it all together. Anything that is not inside of a square root will come in the front, so we have x to the 2nd. Anything that is inside of a square root will go in the back, so square root of 7x. For the denominator, you have a 10 and you have a y that's not inside of the square root. And then you're done. When you multiply by 1, what do you get? Same number, right? So it doesn't matter if we've got the 1 there. The only time the 1 matters is if it's the only thing there. Right? Any other questions? Okay, so you're going to have some practice problems that you need to do and I'm going to check it tomorrow. Make sure you put it on a paper that you don't mind taking out of the notebook just in case I collect it. Huh? Arham is busy right now writing a paper. So, it was not a dumb question. He's just looking out for his friend. Huh? Oh, don't ask questions about what the paper is about? Yeah, don't do that. Mr. McNeely's having him write a paper. All right, there's your homework. Start it now, so that way you don't have to worry about it later. I would prefer